Welcome to Eternal Vault, where planetary mysteries are unraveled layer by layer. Imagine a place so hostile the ocean itself grows weapons, frozen fingers that kill everything they touch. On one hand, the eerie Brinicle, the ice finger of death. On the other, the Doomsday Glacier, a titan whose collapse could redraw our maps. What links them? Salt, cold, Earth's delicate thermostat, and the fingerprints of human influence. Tonight, we decode these deadly mysteries, from microscopic chemistry to global seas. Let's begin. This is Eternal Vault. Subscribe and hit the bell to join us as we decode our planet and beyond. Beneath Antarctic sea ice, the world is silent. Sea stars creep, urchins inch forward, a place that feels eternal. Then, a faint thread of whiteness appears, twisting downward like a ghostly dagger. This is a Brinicle, a frozen stalactite of death stretching from ice to seafloor. Thin, fragile-looking, yet lethal for anything below. When it reaches the seabed, the brine spreads, freezing everything in its path. The secret is salt. When seawater freezes, salt is expelled into tiny brine channels, creating supercooled, dense brine. That brine becomes colder and saltier than normal seawater, able to remain liquid at far lower temperatures. Cracks let this dense brine escape. It sinks, forming a supercooled plume. As it descends, it freezes surrounding water into a hollow sheath. The Brinicle grows as long as brine flows. Slow and steady, it stretches down until it meets the sea floor. When it arrives, everything caught is instantly entombed. For decades, Brinicles were rumors. Early theories surfaced in the 1960s, but in 2011, BBC's Frozen Planet captured one forming in real time, and the footage shocked the world. Starfish were sheathed like statues, no escape. Yet, Brinicles might not be only killers. Some scientists think they could be creators. Their icy walls create sharp gradients, temperature, salinity, and electrical potential, perfect for driving chemistry. Gradients concentrate molecules, an environment where complex chemistry can emerge. Traditionally, life's origin points to hot vents, but cold gradients could also assemble building blocks. If Brinicle-like structures form on Europa or Enceladus, they might incubate life elsewhere in the solar system. So, the same physics that kills life on our seabed could have played a role in creating it. Every paradox in nature carries two faces. From tiny tubes to global ice sheets, Antarctica's forces operate across scales. Next, a glacier so large its failure could rewrite our coastlines, the Doomsday Glacier. Antarctica holds 60% of Earth's fresh water, ice up to 4 kilometers thick. If it all melted, sea levels would rise nearly 58 meters, enough to redraw coastlines. Ice flows like rivers. At the coast, these rivers form floating shelves that act like corks. Thwaites Glacier, roughly the size of Florida, sits in a position of terrifying importance. If this cork fails, glaciers behind it accelerate, dumping ice into the ocean. Its floating shelf slows inland ice. Break the shelf and glaciers surge. Unlike Brinicles, Thwaites is attacked from below. Warm, deep ocean currents eat the ice at its base. Circumpolar deep water, warmer than the surface, flows beneath the shelf, causing intense basal melt. Underwater drones and sonar reveal cracks and cavities hollowing the glacier's foundation. Worse, the bedrock slopes downward inland. Retreat exposes thicker ice, accelerating melt, a runaway loop. Each meter of retreat increases vulnerability. Many experts say the tipping point may be passed. Field teams race to measure changes, but the system is already moving. Complete Thwaites collapse, over 0.65 meters of sea level rise. If West Antarctic follows, up to 3 meters. Cities, islands, and millions of homes are at risk. Mass displacement and economic shock would follow, on an unprecedented scale. Scientists use satellites, ice-penetrating radar, and ocean moorings to monitor the change. ROVs reveal channels where warm water scours the base, vigorous basal melting in action. An international effort tracks Thwaites because its fate affects the whole planet. Models diverge. Some show abrupt retreat within centuries, others longer, but the risk of irreversible change is real. The collapse has begun. The question is speed. How fast will the dominoes fall? If Thwaites and WAIS collapse, global seas climb, coastlines redraw, entire nations vanish. Places like the Maldives and cities like Miami and Shanghai would radically change or disappear. More than 750 million people live in low-lying areas today. Displacement at this scale means migration crises, food insecurity, and geopolitical strain. Mass movement of people will stress infrastructure and governance worldwide. Antarctic ice reflects sunlight, lose that mirror, and darker seas absorb heat, accelerating warming. It's another vicious feedback. Melting begets more melting. The sinking of cold, salty water near Antarctica drives the global conveyor belt of currents. Pouring fresh water from melting ice dilutes salinity, weakening that circulation, already dropping 30–40% in recent decades. Weaker circulation reshapes weather and climate, harsher storms, shifted monsoons, and agricultural disruption. Krill depend on sea ice. Without them, entire Antarctic food webs unravel. Emperor penguins have seen whole colonies fail where ice breaks up too soon. Ports, heritage sites, and economies would be devastated. Insurance, trade, and food systems all hit. Global governance will be tested. Humanitarian responses will need scale and coordination. Uncertainty remains, but uncertainty is not safety. It's a warning. Prepare and reduce risk. Adaptation can reduce harm, but mitigation is essential to avoid the worst outcomes. Antarctica is protected by international treaty, but political and economic pressures will test that compact. Since the 1990s, Antarctic ice loss has increased sixfold. Since 2015, sea ice hit record lows. The culprit, human activity, fossil fuels, land use change, and greenhouse gases. The IPCC warns, keep warming below 1.5 degrees Celsius to avoid irreversible collapses. The choices this decade, on energy, tech, and cooperation, will determine Antarctica's future. Nations invest in science in Antarctica, both for knowledge and strategic presence. The Antarctic Treaty preserves the continent for science. Future pressure will test that agreement. Mitigation requires systemic change and individual pressure to accelerate it. Adaptation, coastal planning, resilient infrastructure can reduce harm while we cut emissions. From the Brinicle's silent whisper to the glacier's thunderous deadline, the ice is speaking. It tells us of life and death, creation and collapse, the same physics writ small and large. We can listen and act. Our choices this decade matter. The race is on. This is Infinite Archive. If this journey opened your eyes, subscribe and tell us, what mystery should we decode next?